Hi guys, this is Mr. Lees doing the higher paper from 2023, paper 2, and we're on question 11 where we are given the equation of two circles and we have to find the distance between their centres. So let's get to that here. So talking about circle C1, it's got equation x take 4 squared plus y plus 2 squared equals 37. In this format here, the centre is the opposite sign of that is the x coordinate, and the opposite sign to that is the y coordinate, and the radius is the square root of that number there, which you see as root 37. Okay, and then for circle C2, we have it presented in a different way. So we have 2g equaling 2, so g is 1, 2f equaling minus 6, so f is minus 3. The centre is the negative of g is the x coordinate and the negative of f is the y coordinate. So that gives you a centre of minus 1 and 3. So these are the two centres. We won't talk about the radiuses in a wee minute, but let's get the distance between the two centres. So we have 4 minus 2 and the minus 1, 3. I tend to get the vector between these 2 points and just get the length of it. So from the x coordinate of 4 to the x coordinate of minus 1 is going back 5, or minus 1 take 4 will give you minus 5. On the y coordinate, you go from minus 2 to 3. That's an upward step of 5, or if you prefer, 3 take minus 2 gives you 5. So we want to get the length of this vector. That will be the distance between the two coordinates. You square each term, add them together, and that gives you root 50, which your calculator says is 5 root 2. And that's the distance between the two centres. So let's go back to get the radiuses. Now I alluded to one of them earlier on. The radius of C1 is root 37, and down here for C2 we had g to be 1, f is minus 3, and c was minus 7. So going by the formula sheet, the radius of a circle presented in this way is the square root of g squared plus f squared take c, which is the square root of 1 squared plus minus 3 squared, take away minus 7, blah, 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 and you get the root of 17. So we have the radius of C1, root 37, the radius of C2 being root 17. So, looking at this bit here, that's just what I've told you there. If I add the two radiuses, root 37 and root 17, the radius of C1 and the radius of C2, I get 10.2. And we had the distance between the centres, 5 root 2, which I switched to a decimal of 7.07. Now, because the sum of the radiuses is more than the distance between the two centres, then, or put it this way, as the distance between the centres of the circle is less than the sum of the two radiuses, the circles intersect at two distinct points, and that does it. Anyone still a little bit unclear? There's a diagram of the two circles. There's C1 and C2. There's the distance between the two centres. That's your 7.07. And there's the radius of one. There's the radius of the other. And as you can see that the two radiuses add up to more than the distance between the centre. That means that the circles have to intersect at 2 points. Yeah, and that's it.